Hello, my name is Tiffany Fugate, and in this video we are going to derive the formula for the sum of a finite geometric sequence. So before we derive this formula, let's look at the sequence that we are going to be summing. Let's look at the first few terms here. We are going to start, the domain of this sequence is going to be the non-negative integers. So a sub 0 is going to be the first term, a sub 1 is going to be that first term in the sequence times the common ratio r. A sub 2 will be a times the common ratio, which would be a times r squared. A sub 3 would be a times r, 3 factors of r, which is a times r cubed. So this pattern will continue all the way to a sub n, which will be a times r to the nth power. So these are what the terms of our sequence look like. Remember that I said that the domain of this sequence is going to be the non-negative integers. This is very important to keep track of, whether or not you're including this a sub 0 term. Okay, it does impact the sum. Alright, so as we sum this sequence, we're going from 0 to n. K is going to be our index, so we're going to, the sequence is going to look like sum a times the common ratio to the k power. Remember, k is the counter, so we're going to be substituting in different powers of k between 0 and n. That's what this notation indicates. I really prefer this notation because it tells you where to start and where to stop in your sequence. Okay? Some people might choose to write it like this, but this is not as descriptive. Alright, so what terms are we going to add? Well, we're going to add these terms here, but we're going to write them like this. Okay, so this is going to be plus a times r plus a times r squared plus a times r cubed plus dot 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 plus a times r to the n. And I'm going to call this equation 1, just to simplify things a little bit. Alright? Now, I'm going to need another equation in order to find the closed form of this sum. I'm going to call the next equation 2, and what equation 2 is going to equal is equation 1 times a factor of r. Okay, so that's going to be r times the sum as k goes from 0 to n of a times r to the k, or r times s sub n. And then each of these, according to the distributive property, would get an extra factor of r. So every term, the power on the r will increase by 1, or the exponent on r. Alright? So there is your equation number 2. Alright? So now, we have two equations. In order to find the closed form, we're going to take equation 2 and subtract from that equation 1. Alright, so what that's going to look like, over here you have coefficient of r and a coefficient of 1. So you're going to have r minus 1 sums, as k goes from 0 to n, of a times r to the k. If you remember your properties of sums, that factor of a could come out at any time. Okay, and then the interesting thing that happens with these terms is, notice that this term will remain, a times r to the n plus 1. Alright, and then over here, this term minus this term, these terms will cancel, as well as this will have a matching pair. These will cancel, these will cancel, these will cancel, and so you're left with minus a. Alright. Now the only thing left to do is divide all of these by r minus 1. So the sum and that a will factor out. Now remember, I told you right here, if we kind of just ignore this piece right here, this a will factor out of the sum as well, so we could write this in this fashion. So both sides of the equation will now have a factor of a, so we could divide both sides by a, and that a becomes arbitrary. And now let's think about possibilities for that common ratio. If your common ratio in absolute value is between 0 and 1, then this term here is going to go to 0 as n goes to infinity. So if that's the case, then this sum is going to be, will be 1 over 1 minus r if the absolute value of r is between 0 and 1. If r in absolute value is greater than 1, then this thing is, this sequence or this sum will be divergent. This thing is going to keep getting bigger and bigger. So that has another impact on this sum. So if we're thinking about series when we get into calculus, you'll deal with what happens if the sequence is divergent or convergent, what will happen to the sum. But this is another interesting point that needs to be brought out here. Okay? Thank you very much.